In previous lessons, we discussed how 5G networks will revolutionize many industries. Drones are expected to bring even greater changes to society when they start using 5G networks. Drone is a buzzword over the recent years. Many people are already familiar with the technology, given that it has entered our daily life. International authorities predict that by 2020, 5.76 million civilian drones will be sold, with global market value scaling up to $127.3 billion. If manufacturers integrate 5G technology into their drones, double that number of drones will be sold. Creating synergies between 5G and drone technologies is an exciting prospect. However, before we look at what the future holds, let's first look at what drones are currently used for. Police drones, known as the Air Police, have high-definition cameras and thermal sensors to help law enforcement officers investigate suspects and hunt down criminals at night. Police drones also collect data that is used to prevent forest fires and for traffic controls, daily patrols, and city security. Drones also play a significant role in the energy industry. They are used to inspect power lines, oil pipelines, and natural gas pipelines. Drones have replaced maintenance workers who found it difficult to conduct long-distance inspections and who couldn't work when there were natural disasters, such as snowstorms, earthquakes, and landslides. The patrol in mountainous areas is pretty risky, always putting patrol personnel's lives at stake. Equipped with inspection devices such as infrared thermal imagers and sensors, drones rise as a new alternative to provide aerial inspection. Drone boasts greater efficiency, responsiveness, inspection range, and reliability when compared with human inspectors. Communications is not immune to natural disasters. When communications networks are down because of natural disasters, drones can carry small base stations to the affected areas. In this way, creating temporary communication networks, drones can also be used in a similar way to provide networking signals in complicated or demanding conditions. Drones are helpful in geography and resource management. Drones with optical lenses and imaging sensors can create 3D maps of buildings and obtain various geological data. As a result, drones have been a popular tool in urban planning, mineral extraction, asset counting, and mapping and surveying. Drones also have a wide range of other uses in areas such as agriculture, logistics, site surveys, and disaster prevention. However, drones are still used for limited purposes. There are three principal issues to consider in relation to its universal application. First, it is difficult to come up with feasible drone regulation. Many countries ban the flying of drones near high-security installations, such as airports and military bases. Nevertheless, there are still cases of drones causing flight delays or otherwise disrupting air traffic. This is largely because drones are difficult to regulate. Regulators do not have feasible ways of finding out when drones take off or what their real-time locations are. Drone owners are also not required to provide identification when they buy most types of drones. This makes it hard for regulators to trace drones involved in wrongdoing back to their owners. Therefore, to prevent drone-regulated regulatory burden, many countries have simply issued comprehensive flight bans on drones. Second, data networks place limits on drones' operational ranges. The data that drones collect and drones' operational inputs are transmitted over wireless networks. Some short-distance drones use Wi-Fi networks. This limits their flight height and radius, makes it difficult for them to transmit high-definition or ultra-high-definition video. Wi-Fi networks are also vulnerable to security risks, which limits the use of Wi-Fi-enabled drones in enterprise settings. Third, battery capacity also limits drone use. Many drones have an average battery life of about 20 minutes. Drones' short battery life and the difficulty of remotely charging them while they are in the air has dampened businesses' enthusiasm for drones. These obstacles to drone development reflect the requirement for 5G. the priority is to connect drones to operators' 5G networks. It is useful at this point to explore why only 5G networks can remove these limits and not 3G or 4G networks. Traditional 3G and 4G networks are mainly designed to allow people to connect to wireless networks, so they have limited capacity for providing network signals at high altitudes. The recently developed 5G networks, in contrast, are specifically designed to be able to connect everything, including drones. Now, let's take a look at how drones fly with 5G. 5G networks can enhance regulators' monitoring of drones. Regulators can build a monitoring platform for drones that allows 5G connected drones' flight locations and statuses to be sent back to the platform. The supervision agencies, therefore, will keep a close eye on drones and ensure that all drones' flights are orderly. This regulatory supervision could be enhanced by requiring drone owners to use their real names when signing up for 5G networks. Second, 5G networks' massive MIMO technology can help drones fly at higher altitudes than current wireless networks. In the future, drones can fly higher and have their wings unclipped. In addition, the ITU has set the benchmark transmission rate for 5G networks to 10 gigabits per second. As such, the large bandwidth provided by 5G networks allows 5G connected drones to use more advanced cameras and sensors that require real-time backhaul of large amounts of data. Third, 5G networks can also alleviate businesses' concerns about drones' low battery capacities. Cellular network base stations are normally 500 meters away from each other, which is closer together than most bus stations. Huawei and other companies are working with network operators to turn their base stations into charging stations. Either wireless or wired charging options could be provided, depending on how drones' charging ports are set up. This would provide a dense network of charging options for drones. After these obstacles are overcome, drones that are 5G enabled would support more sensors and would be able to take advantage of big data analysis and artificial intelligence to collect better data. These drones would have a positive impact on industrial security, oil and electricity production, and in the setting up and running of smart cities. With 5G, the future of drones looks more promising than ever, and the data value brought by drones is much more anticipated. That's all for this class. In our next lesson, we'll discuss the impact 5G networks will have on cloud VR.